Welcome to Teach Me Physics. What is ozone? Ozone is a naturally occurring gas composed of 3 oxygen atoms, O3. It is present in small quantities in the Earth's atmosphere, primarily in the stratosphere, where it plays an important role in absorbing and blocking harmful ultraviolet radiation from the sun. Ozone is also formed in the lower atmosphere, troposphere, as a result of chemical reactions involving pollutants from human activities, such as cars and industrial processes. In the troposphere, ozone is a harmful air pollutant and a major component of smog. While ozone in the stratosphere is beneficial, ozone in the troposphere is harmful to human health and the environment. Where is ozone located? The ozone layer is located in the Earth's stratosphere, which is the layer of the atmosphere that lies roughly 10 to 50 kilometers, 6 to 30 miles, above the Earth's surface. The majority of the Earth's ozone, about 90%, is found in the stratosphere, between 10 and 50 kilometers, 6 to 30 miles, above the Earth's surface, in a region known as the ozone layer. This layer is primarily responsible for absorbing and blocking the sun's harmful ultraviolet, UV, radiation. Discovery of ozone. One of the key figures in this research was a British scientist named G.M.B. Dobson, who developed the Dobson spectrophotometer in the 1920s. This instrument was used to measure the concentration of ozone in the Earth's atmosphere, and it allowed scientists to better understand the distribution and behavior of ozone in the atmosphere. Other important contributions to the understanding of ozone and its role in the atmosphere came from scientists such as Paul Crutzen, Mario Molina, and F. Sherwood Rowland. In 1974, Molina and Rowland proposed that chlorofluorocarbons, CFCs, could be damaging the ozone layer, and their work helped to stimulate further research on the topic. In recognition of their contributions to the study of ozone, Crutzen, Molina, and Rowland were awarded the Nobel Prize in Chemistry in 1995. Today, the study of ozone and its role in the atmosphere remains an active area of research, as scientists continue to work to better understand this important component of our planet's environment. Function of ozone. Ozone, O3, plays a crucial role in the Earth's atmosphere and has several important functions, including protection against UV radiation. Ozone in the Earth's stratosphere absorbs most of the sun's harmful ultraviolet, UV, radiation, preventing it from reaching the Earth's surface. This protects life on Earth from the harmful effects of UV radiation, such as skin cancer, cataracts, and damage to crops and ecosystems. Climate regulation. Ozone is a greenhouse gas, meaning that it helps to regulate the Earth's temperature by trapping heat in the atmosphere. This is important for maintaining a habitable climate on Earth. Air purification. Ozone in the lower atmosphere, troposphere, can help to purify the air by oxidizing and removing pollutants such as nitrogen oxides and volatile organic compounds. Atmospheric chemistry. Ozone plays a key role in the chemistry of the atmosphere, participating in reactions that help to regulate the levels of other important gases such as carbon dioxide and methane. Overall, ozone is a critical component of the Earth's atmosphere, and its functions are essential for maintaining a healthy and habitable planet. What is ozone hole? The ozone hole is an area of the Earth's stratosphere where the concentration of ozone, O3, is significantly reduced compared to normal levels. The hole is not actually a physical hole, but rather a region with low ozone concentrations that is shaped like a circle or oval. The ozone hole is caused by the release of man-made chemicals called chlorofluorocarbons, CFCs, into the atmosphere. These chemicals react with ozone in the stratosphere, breaking down the ozone molecules and depleting the ozone layer. The largest and most well-known ozone hole is the one that forms over Antarctica each spring, but ozone holes have also been observed over other regions of the world, including the Arctic and parts of the mid-latitudes. The ozone hole is a significant environmental problem because it allows more harmful UV radiation from the sun to reach the Earth's surface. This can have a range of negative impacts on human health, including increased rates of skin cancer, cataracts, and immune system suppression. It can also have ecological impacts, such as damage to crops and marine ecosystems. How ozone hole is formed. The ozone hole is formed as a result of complex chemical reactions involving human-made chemicals called chlorofluorocarbons, CFCs, which were widely used in refrigeration, air conditioning, and aerosol sprays until the late 1980s. When CFCs are released into the atmosphere, they can eventually make their way into the stratosphere. There, they are broken down by UV radiation, releasing chlorine atoms, Cl, that can then react with ozone, O3, molecules, breaking them apart and reducing the amount of ozone in the stratosphere. The chlorine atoms react with the ozone molecules in a catalytic cycle, meaning that a single chlorine atom can destroy many ozone molecules before it is ultimately removed from the cycle. This is what leads to the severe depletion of ozone over the Antarctic region, where cold temperatures and unique weather patterns create conditions that enhance the catalytic destruction of ozone. The ozone hole is typically observed during the Antarctic spring, September to November, when temperatures in the stratosphere start to warm up and trigger the release of chlorine atoms from CFCs. The size and severity of the ozone hole vary from year to year, depending on weather patterns and the amount of ozone-depleting chemicals in the atmosphere. However, since the adoption of the Montreal Protocol in 1987, which is an international agreement aimed at phasing out the production and use of ozone-depleting substances, the amount of these chemicals in the atmosphere has been decreasing, and the ozone hole is showing signs of recovery. How can we recover ozone? The recovery of the ozone layer depends on reducing the amount of ozone-depleting substances, ODSs, in the atmosphere. Stricter controls on the use and disposal of ODSs, including refrigerants, solvents, and foam-blowing agents. It is important to note that the recovery of the ozone layer is a slow process, and it may take several decades or more to fully recover. Another video.